In this video, we're going to discuss the solutions to the final exam on single variable calculus or calculus 1 in spring semester 2017. Exam contains 2 parts. The first part contains 5 questions to test the technical skills, and the second part contains 6 problems on the following topics. So let's go through the questions on the first part. So the first question, we're given a function. We need to find its derivative and evaluate its derivative at the x is equal to 1. So in order to take a derivative, we're going to use the quadrant rule. So the quadrant rule was given to take the derivative of the ratio of the rational function. If you're given the ratio of the two functions which depends on x, and its derivative is going to be f prime of x multiplied to the g of x minus f of x multiplied to the g prime of x divided to the g square of x. So that is why let us take the derivative of ln of x over x squared using this formula. This is going to be derivative of the ln, which is going to be 1 over x multiplied to the x squared minus the first function ln of x multiplied to the second derivative of the second, which is tx, divided to the x in the power of 4. So we need to evaluate this derivative at the x is equal to the 1. So let's substitute 1 to all x's here. It's going to be 1 minus ln of 1 multiplied to the 2 multiplied to the 1 divided to 1 in the power of 4, or simply this is going to be equal to the 1 since ln of 1 is equal to the 0. So the answer is 1. So the second problem, we need to integrate this function, and I remember the rule that if I see a function and its derivative inside the integration, I can use the substitution. We're going to use the substitution. U is equal to the x cubed plus 1. So that is why the differentiation of the u is going to be equal to the 3x squared dx. So I have substituted 3x squared dx with a du, and sine of x cubed plus 1 is a sine of u. So this integration of the 3x squared sine of x cubed plus 1 dx is going to be written as integration of sine of u du, which is simply cosine of u plus some constant c. So if you want, you can write this in the form of cosine x cubed plus 1 plus the constant if you want to resubstitute back the function of the x. So the answer is cosine of x cubed plus 1 plus some constant. So the problem number 3 is we need to evaluate the derivative of this function, and we're going to use the chain rule. So the chain rule tells me that if I would like to take the derivative of the f which depends on the x implicitly, so basically f depends on g, which depends also on x, then if I would like to take its derivative with respect to the x, so first of all I need to take the derivative of the f with respect to the g, then multiply this to the derivative of the g with respect to the x. So basically here you see, so it is like ln depends on some function x squared plus 1 which depends on x, right? So that is why the derivative of the ln of x squared plus 1, so I'm going to take its derivative with respect to the x squared plus 1. Basically I'm going to take x squared plus 1 as one variable, as x for example, right? So this is going to be equal to the 1 over x squared plus 1. If it would be just ln of x, it would be 1 over x, right? So ln of x squared plus 1, it's going to be 1 over x squared plus 1 because I'm taking this variable as one variable and multiply this to the derivative of this function, which is tx. So the answer is tx divided to the x squared plus 1. Problem number 4 is on the composite functions. Basically, it's easy, straightforward. We just need to evaluate the g of 4 and then evaluate the f of g of 4. So let's evaluate g of 4. It's going to be equal to, I just need to substitute 4 with this x and with this x. It's going to be square root of 4 plus 1, which is going to be equal to the 3. So f of g of 4 is going to be equal to the f of 3. So now I need to substitute this x, and this x was the 3, it's going to be 1 over 3. So the answer is 1 over 3. Problem number 4 is on the indeterminate limits. So the limit of sine square of x divided to the 1 minus cosine of x. When x goes to the 0 is going to have the 0 to the 0 form, because when x goes to the 0, this function goes to the 0, and this function on the denominator also goes to the 0, since cosine of 0 is equal to the 1. So the L'Hopital's rule says us that this limit is equal to the limit of the function when I take the derivative of each of the functions on the numerator and on the denominator separately. So this is going to be equal to the limit of x goes to the 0. So derivative of the sine square, I'm going to use the chain rule again. So I need to see this as some function in a square, or x in a square. So if I take the derivative of the x square, it would be 2x, right? So here in my case, my x is not just the x, it is sine of x. So that is why it's going to be 2 multiplied to the sine of x. But additionally, I have to multiply this to the derivative of the sine, which is cosine of x. Divided to derivative of the 1 is 0, and derivative of the minus cosine is going to be equal to the plus sine of x. So I can eliminate this sine and this sine, and when x goes to the 0, cosine of x goes to the 1, so that is why the answer is going to be equal to the 2 simply. So these are the problems on the first part. So let's go to the second part. In the second part, we need to start with this problem when we need to find the length of this curve, which is given parametrically. And we are going to find the length of the curve, of the parametric curve, using the formula. So derivative of the x with respect to the t in the square, plus derivative of the y with respect to the t in the square, then the square root with respect to the t, where t is going to change from 0 to the 1, right? So let us find the derivative of the x with respect to the t first of all. So x is in our case is the cosine, so its derivative with respect to the t is minus sine of t. So derivative of the y with respect to the t is y is equal to the sine, so its derivative with respect to the t is simply cosine of t. So I'm going to substitute dy dt was the cosine, dx dt was the minus sine, so this formula becomes from 0 to the 1, square root of sine square of t plus cosine square of t from the square root dt, and this is equal to the 1. So sine square plus cosine square of t is equal to the 1. So this integration becomes integration of 1 dt from 0 to the 1. So I just evaluate this using the Newton-Leibniz formula. It's going to be t, and we need to evaluate this at the 0 and 1. This is going to be equal to the simply 1. So the second problem is about the rate of change and the meaning of the derivative. So it is given that the rate of change of the volume with respect to the time is equal to the 24 centimeters cube with the minus, because it's decreasing, right? And we need to find the rate of change of the side of the cube. So before we start, let me remind you the formula of the v. So in our case, it depends on time. This is equal to the side, which depends also in the time in the cube, right? So derivative of the v with respect to the time is going to be equal to the 3a square multiplied to the derivative of the a with respect to the t according to the chain rule, because a is also some function which depends on time, right? So at the same time, the meaning of this ratio is the rate of change of the volume with respect to the time, right? And the meaning of this term means the rate of change of the side of a cube with respect to the time. So derivative of the v with respect to the t, it means it's what is the rate of change of the volume with respect to the time. So the rate of change of the side with respect to the time would be, in this case, dA dt would be, so this dv dt is given already, right, which is minus 24. It would be minus 24 divided to the 3a square, okay, or minus 8 divided to the a square. At the same time, we're given that initially the volume was equal to the 8, so initial side of the cube was a cube was equal to the 8, so that is why initial side of the cube was equal to the 2. I just need to substitute this here. It's going to be minus 8 over 4, or simply minus 2. So the rate of change of a side of a cube with respect to the time is equal to the minus 2. It means that every second the side of a cube is decreasing by 2 centimeters. Okay, so it's minus 2 centimeters per second. Problem number 3, it's on the volumes. We're given 3 curves, and we need to define the region and round this around the y-axis and find the volume of a solid which we obtain by rotating this region. So let us try to draw this. So we are going to draw the 3 functions. So y is equal to x is equal to the 0. It's a curve when all the points on the x line are equal to the 0. So this is basically this line. This is the x is equal to the 0. So x is equal to the 2y. It's easy to draw. You can draw this as y is equal to the x over 2, or you can draw this by defining 2 points, right? So let's define. So let's choose x to be equal to the 0, then y is equal to the 0, right? If you choose x to be equal to the 2 or 4, let's say, y is going to be equal to the 2. If you choose x to be equal to the 4, then y is equal to the 2. So this curve is going to be like this. It's assumed like this, roughly. And this is y is equal to the x over 2, or x is equal to the 2y. So, and the third one is y is equal to the 9. Let me draw this here. So this is going to be a horizontal line where y is equal to the 9. So all the points on this line have the y coordinate to be equal to the 9. So we've got this region, and we need to rotate this around the y-axis, right? If you rotate this, we're going to roughly get this kind of curve, this kind of object. So we are going to rotate this, and this side is going to be a circle. Okay, so we need to find its volume. In order to find its volume, we're going to make the horizontal slices. So let's decide to make a slice here at some point y. If you make a slice, you're going to get a circle, right? So the area of the circle can be found by multiplying the pi to the square of the radius of the circle. If you decided to cut this at some point y, then the coordinates of this point is going to be equal to 2y and y, right? Because you can find the x coordinate of the point by putting the y value to here, right? So x is equal to the 2y and y is equal to the y. So if you cut this at this point, the coordinates of this point is going to be equal to the 2y and y, and the radius of the circle, of this black circle, is equal to the x coordinate of the point, which is equal to the 2y, right? So the area of this circle is going to be equal to the pi r square, or equal to 4y squared multiplied to the pi. So we can find a volume of this object by integrating the area, function of the area, which depends on y with respect to the y, where y is going to change from 0 to the 9. Or basically it is going to be integration from 0 to the 9 of the 4y squared pi dy. If you integrate this, we're going to get 4y cubed over 3 pi from 0 to the 9. We just need to substitute the 9 and 0. This is going to be 4 multiplied to the 9 and a cube over 3 pi. If you put the 0, it's going to be simply 0. So this is the volume of this object which we're going to obtain. Problem number 4 is it's about a fundamental theorem of calculus. We're given a function which depends on x. And actually this x is on the border of the integration. So the fundamental theorem of calculus tells me that the derivative of this function is equal simply to the function which is inside the integration, which is sine, right? And instead of t, I just need to divide the x, according to the fundamental theorem of calculus. So in the second part of this problem, we need to identify the regions where this function is increasing, okay? Where the function f of x is increasing. F of x is increasing. So the function is increasing if its derivative is positive in that region. So let us draw the derivative of this function. or basically sine of x. So at the pi over t it's going to be 1, at the pi it's 0, at the 3 pi over t it's minus 1, and at t pi it's again 0. So let me draw this. It's going to be 1 here and 0 here, minus 1 and 0 again here. So this is the function f prime of x, which is sine of x, right? So derivative of our function. So derivative of our function is positive in this region for all the points of the x between 0 and pi. So f prime of x is positive, so therefore f of x is increasing. And for all the points of the x where x changes from pi to the t pi, f prime of x is negative, so that is why f of x is decreasing. Okay, so let's go to the problem number 5. It's on the integration of a rational function. So in order to integrate this function, we are going to split this into the two parts, basically. So I can write as x over 4, x minus 4 divided to the x squared minus 5x plus 6 as x minus t multiplied to the x minus 3. Okay, because if you open up the brackets, you're going to exactly have x squared minus 5x plus 6. So now, I would like to rewrite this rational function as the two rational functions. I would like to write as some constant divided to the x minus t plus another constant divided to the x minus 3. Basically, I would like to figure out the values for the constants a and b, so that when I sum these two rational functions by given the common denominator, I'm going to have exactly this one. Okay, so in order to find the values for the coefficients, I would like to give the common denominator and equalize these two rational functions. If I give the common denominator, it's going to be a multiplied to the x minus 3 plus b multiplied to the x minus 2 divided to the x minus 2 x minus 3. Let me open up all the brackets. So this is going to be ax minus 3a plus bx minus 2b divided to the x minus t, x minus 3. So this rational function should be equal to this one. Let me equalize them. So x minus 4 divided to the x minus t, x minus 3 should be equal to, so I'm going to regroup those terms. I would like to write as x multiplied as a plus b, and the free coefficient is going to be 3a minus tb divided to x minus t, x minus 3. So I see from here that the denominators are the same, and in order to equalize the numerators, so on the numerator I've got two polynomials, and the two polynomials are equal if and only if their coefficients before the powers of the x are the same. So the coefficient before the x on the left is 1, so this should be equal to the a plus b coefficient of the x on the right hand side. And the free coefficient is minus 4 on the left, and this should be equal to the minus 3 minus tb. So I'm going to find a b from the first equation. This is going to be equal to the 1 minus a, and I'm going to substitute this to the second. This is going to be 4. Let me multiply everything to the minus in the second equation. It's going to be 4 is equal to 3a plus 2 multiplied is 1 minus a. I'm just going to substitute the b was 1 minus a. If I open up the brackets, it's going to be 4 is equal to the 3a plus 2 minus 2a, right? If this 2 goes there, so 3a minus 2a, it's simply a. So a becomes equal to the 2, and I can find a b by subtracting 1 minus a, which is going to be equal to minus 1, right? So the value of the b here, it's going to be equal to the minus 1. The value of the a is equal to the 2. If I substitute t and minus 1 to the a and b, if I sum the two rational functions here, this is going to give me exactly the initial one. So that is why the integration of x minus 4 divided to the x minus 2 multiplied to the x minus 3 dx can be written as the integration of the t divided to the x minus t dx minus 1 divided to the x minus 3 dx, right? So I put the minus of the minus 1 t outside the integration. So the integration of the first part is going to be t multiplied to the ln of x minus t, and integration of the second part is going to be ln of x minus 3 plus some constant. So the last problem is on the optimization problem. A poster must have to be printed to the area of 320 centimeters square. It will have top and bottom margins of 5 centimeters and side margins at 4 centimeters. What are the dimensions of the poster with the smallest total area? Okay, so we are given a poster and it has the top margin and a bottom margin at a distance of 5 centimeters, and the side margins are at the distance of 4 centimeters. Okay, 4 centimeters. So we are given that a printing area, this area, is equal to 320 centimeters square. So we need to find the area of the dimensions of this poster so that the area becomes a minimum. So let me denote the printing area width as x and height as y. So basically x multiplied to the y should be equal to the 320 centimeters square, and the total area of a poster is going to be equal to the x plus 4, right? Sorry, x plus 8 this is going to be the total width here is going to be x plus 8, and the total height of the poster is going to be y plus 10, right? X plus 8 and y plus 10. Y plus 10, it's the total area. Total area is going to be equal to this. So we need to minimize the total area. So in order to do this, so it depends on two variables, x and y. We need to get rid of one of them. So in order to get rid of one of them, I'm going to use this equation. From here I can find that y is equal to the 320 divided to the x, and let's substitute this with this y here. So the total area is going to be equal to, let me open up the brackets first of all, it's going to be xy, right, plus 10x plus 8y plus 80. So xy is equal to the 320, right, that's given, plus 10x plus 8y is equal to 8 multiplied to the 320 divided to the x plus 80, right? So this is going to be equal to 400, right, 320 plus 80 plus 10x plus 8 multiplied to the 320 divided to the x. So this is the function of the total area, which depends only on x. So in order to maximize this or minimize this, we need to take the derivative of the total area with respect to the x and equalize this to the 0. So derivative of this function with respect to the x is going to be equal to derivative of the 400 is 0, derivative of the 10x is equal to the 10, right? And derivative of this part is going to be equal to minus 8 multiplied to the 320 divided to the x squared, right? Because you remember x in the power of minus 1, its derivative is equal to minus 1 multiplied to the x in the power of minus 2. So this is equal to the 0. I need to equalize this to the 0. So basically x squared is going to be equal to 8 multiplied to the 32, 320 divided to the 10, or 8 multiplied to the 4 multiplied to the 8, right, divided, or that's it, okay, because I wrote the 32 as 8 multiplied to the 4. So this is going to be 4, 8, right? So that is why x is going to be equal to 8 multiplied to the 2, right? Square root of this term is going to be equal to the 8 multiplied to the 2, because it's like a 8 square multiplied to the 2 square, so which is 16. Okay, so in order to know that for this value of the x the total area is minimum, we need to take the second derivative of the total and check the sign of the second derivative for this value of the x. So let's take the second derivative of the total, with respect to the x. So this is going to be equal. So derivative of the 10 is equal to the 0 minus derivative of this one is going to be minus 2 comes down, right? It's going to be plus 2 multiplied to the 8 multiplied to the 320 divided to the x cubed, right? For the value of the x of 16, so the second derivative, so if I substitute x is equal to the 16, is going to be positive, right? If the second derivative is positive, then the function reaches its minimum at this point, right? Because the function is going to look upward, so that is why at this point x, the function reaches its minimum. So at the x, the total becomes, at the x is equal to the 16, the total area becomes minimum. So let me find the total area or dimensions of the poster. So if I substitute x to be 16, this side is going to be equal to the 24, right? So what was the y? So y was equal to the 320 divided to the x, which is 16, right? So this is going to be equal to 20. And this side, the height of the poster, is going to be equal to the 30. So dimensions of the poster are 24 and 30, and in this case the poster is going to have the smallest area under the constraint that the printing area is equal to the 320 centimeters square.